Okay, I thought I'd do another video on this Victor projector amplifier. I made some mistakes that in what I said in the last video clip. I said that these tubes were wired in parallel. Well, I counted on the base wrong when I traced the wiring. These are indeed 6L6 tubes in push-pull configuration in the amplifier. So I was wrong there. The other thing that confused me is this tube here is a 6SJ7 and the base calls for 6J7. Well, a 6SJ7 will replace a 6J7, but the base has to be rewired. The base wiring is not the same. So I traced the base wiring, and sure enough, this amplifier is wired for a 6SJ7 tube. Okay, so here's the other thing that I think I made a mistake. Here is the choke right here, and it looks kind of cooked, but it's actually not. I think that choke's probably okay. The brown gook on it and everything came out of the power transformer here. So what happened is this is a 5V4 rectifier, and it shorted and it cooked the transformer when somebody put a 20 amp fuse in the fuse holder, which before the fuse blew, it was on long enough to really fry up this transformer. So the transformer shot. There's no question about that. This is not a 40B amplifier, even though that in the projector was a schematic for a 40B. What this actually is, it's a Model 60 amplifier, and how I know that is I downloaded the complete service manual for Victor projectors, and the 40B has a round receptacle for the exciter lamp and the pilot light. In this case, it's a square one, and that's the Model 60. So I've got that kind of figured out, that this is a Model 60 amplifier. The card that was in it, the 40B schematic, that threw me off track. What else have I figured? Well, like I say, the 5V4 tube shorted. The short is between the transformer and the choke, not on the output side of the choke, so chances are the choke is still good. I would check it out. Now, I have a transformer that I think would work, and that's this one right here. Now, this is, I think, about 650 volts center tapped, which by the time it's filtered and rectified should be around maybe 330 to 340 volts plate voltage. At least that's what I think. And the schematic for a 60 amplifier calls for 340 volts on the plate. Now that's fine and good. These yellow wires here, that's the 5 volts for the rectifier filament. There's a problem. The exciter lamp and the pilot light are not 6.3 volts, they're 5 volts. And I believe the exciter lamp, here it is, the exciter lamp, I think that's like a 6 amp draw, according to what I read in the schematic. So, wow. Where do I get the 5 volts at 6 amps? Well, this is a pail of worms. It really is. How far do I want to go with this project? I never figured that I'd end up with something with a burned out transformer. I mean, that was the last thought in my mind when I bought this projector as a project. I thought I'd be rebuilding, putting new capacitors in, and it would have a good transformer. By the time I got all new caps in, the tubes all checked out, the thing would work. Never counted on this thing being fried. So what do I do with it? Well, I can get 5 volts DC at 8 amps in a small power supply, and I could fit it in somewhere. I don't know if it'll make any difference if I power the exciter lamp with AC or DC. It may not make any difference. I don't know. It might not. It's hard to say if that'll make a difference. I could put a solid state rectifier in place of the tube and use the 5 volts here to power the exciter lamp. I don't know what I'm going to do with it at this point. I'm really not sure how far I want to go with it. I had this transformer on hand, so I didn't have to buy this. And I did buy a 6.3 volt filament transformer to run the filaments, so that I could put this on a variac connected in after I replaced these electrolytics and slowly bring the power up to see if I can actually get this thing to work with some of these old capacitors still in it. I'm not sure if I'm going to do that or not now. I've never worked on a projector amplifier before, so I did not know that the exciter lamp runs on 5 volts, not 6 volts. So that's a dilemma. This transformer apparently had 2 5-volt windings, one for the rectifier and one to feed the exciter lamp. So I don't know where I'm going to go with this. I'll see. In the next clip after this, maybe I'll show where I'm doing some experimenting with it and trying to trace out the circuit. The 60 amplifier schematic that I have is pretty good, but I'm going to have to pull this off, cut the wires as long as I can cut them, and try to trace out where the wires go so I could label the wires to know what is what, because this thing has got to go. The transformer is shot. So that's about it for now. Take a look at this transformer. Boy, this thing really cooked. When they put a 20 amp fuse down, let's see right here, they put a 20 amp fuse in there. I wonder if they plugged this into a 15 amp circuit or a 20 amp circuit in the house. It would have popped the breaker if it was a 15 amp. Boy, they really fried this transformer. That's really something. Okay, I've cut the transformer windings so that I could take this off. Take a look. Wow. Isn't that melted? It blew the 20 amp fuse that they put in there, but I kind of was thinking, I wonder if they had it plugged into a 20 amp circuit in the building that they plugged it in when they put that big fuse in there. If they had it in a 15 amp circuit, I would think that it would have blown the breaker or the fuse, the house fuse, before it blew the fuse, the 20 amp fuse in here. I don't know, it's very strange. But they fried it pretty good. Maybe they put more than one fuse in. Well, that one blew, let's put another one in. Well, anyways, we know where that is. So I've labeled all the wires. I know where these go, which ones are the filaments, which ones go to the B+, the 5 volts to the rectifier. These leads here are the power leads that go in the transformer. What isn't there? There's something not there. The voltage that runs the exciter lamp is not there. And yet on the schematics it shows that it comes out of the power transformer. But in this case, unless there's invisible wires, I don't know. Here are the wires that go to the exciter lamp circuit. I'm kind of thinking that either this is an audio out transformer, and the little transformer on the other side is a 5-volt transformer for the exciter. The schematics don't show that, and I downloaded the entire Victor Projector service manuals for these, and yet on the schematics it shows that the 5-volt winding for the exciter lamp and the little pilot light that's on the projector itself comes off the main transformer, but I've labeled all the leads and there's no other output other than the 5 volts that goes into the rectifier tube, and I know darn well that that 5 volts can't be the same. You know, they wouldn't have that connected together. I can't imagine that they would. So I got to do some more tracing to figure out where all these wires go and figure out what I'm going to do with this thing. Okay, let me explain what I've got going here. This looks like a mess, I know. These electrolytic capacitors right here replace these two. And what I'm doing is I'm using this transformer to provide the high voltage, which I think is going to give me maybe 320 volts DC. I'm not really sure. I'm going to run it up quite slow when I do that. But this transformer here, that's just feeding the filaments, because what I'm doing is this is a solid state rectifier replacement here, so I'm just using this so that I can bring the B plus voltage up quite slowly. I'll have the filaments already heated up in these 4 tubes from a separate transformer. So this transformer I'll bring up with the variac, the variable AC supply, quite slowly. I've got all these hookups in here. Nothing is shorted. I'm pretty positive I've got everything in the right place. These leads down here, these double leads, my hand's in the way, but these leads are the actual, was the 5 volt supply for the exciter bulb off the transformer. That of course I don't have to connect anything to now. 2 electrolytics connected to ground. One on each side of the choke. Now I checked across and I get 200 ohms on the choke and nothing to ground. So I'm pretty sure that choke is good. I don't think the only reason it looks the way it looks is because when the power transformer degassed down into, and that was the only place it could degas to, is down through the holes where the wires came through, and kind of filled this whole thing with a combination of gas and tar. It must have been spectacular. I wish I could have seen it. So anyways, what I'm going to do is I'm going to feed in I'm going to feed a signal into it, connect the speaker up to it, feed a signal into the phono input, and see if I can get, I'm not replacing any of these other electrolytics or the wax capacitors that are in there, and just, they might work, they might not. I don't know if they're going to short, they might. But I'll bring the power up slowly, and I'll be watching it to make sure that nothing's going to fry up. I'll be measuring the B plus voltage as I bring it up. So that's what I'm going to do with this amplifier so far. And to show you that the filaments do light from that transformer, let me get some lighting off here. We power this thing on. And yeah, see, they're lighting. The tube's all light. So that's just off of my filament transformer supply. So that's how I'm going to do it. I'm going to run the big transformer up gradually, measuring the B plus. I'll have the tubes all powered up. I'll be using that solid state rectifier here, and we'll see what we get. Maybe we'll get nothing. One never knows. Could just get smoke. Might get noise. I don't know. So what I'm doing here is I'm going to run the power of the transformer up until I get to well, I think this thing is going to run at about 340, 350 volts B plus. But I have all the tubes out, so there's no load on it. And so it's through a solid state rectifier. It's probably it could possibly exceed the 450 volts that these capacitors are rated for. So what I'm going to do is I'm going to bring the power up slowly and just see what we get for voltage. That's DC volts, B plus. And I'll raise it, we'll put it at 350. That's 100 volts below the rating of the electrolytic capacitors. There we go, 149, 349. So I'm only at 95 volts. But it'll be different when I have the power tubes plugged into it, the power amplifier, the 6L6s, the other tubes, because that'll put a load on it. So I suspect that the voltage will be less. Now whether or not I could really use this transformer or not, that's debatable. But I'm all set to actually test the electronics on it now to see if I get any audio through it. I'll set that up and I'll try that. All of these smaller electrolytics like this one here, there's several in here, plus these wax capacitors. I'm not going to change any of those unless I know if this thing's going to work at all. What I'm doing right now is not what I had planned to do. I had not planned to do this at all. I hadn't counted on the transformer being fried, and boy was it fried. I mean, it's charcoal. Here it is. That baby is really fried. It must have smoked pretty good. Well, you put a 20 amp fuse in it. It cooked pretty good before it blew the fuse. Okay, so the next phase, I'm going to try it with the speaker plugged in, the power tubes in it, and hopefully maybe the old capacitors will work good enough where I could actually get some audio through it. So I have the tubes warmed up. I'm going to start putting DC into it. We have the speaker over there. Okay, so this power transformer is not going to work because the voltage is too high. So this wouldn't work. Pots are really dirty. So I'm only at so if I bring it up to 120 volts, if I bring it all the way up to 120 volts, the B plus voltage is going to shoot up too high. So I'd have to get a transformer that maybe is 500 volts center tap, maybe. I don't know, but anyways, the amplifier works with those old wax caps in it, the remaining electrolytics. It's pretty amazing, isn't it? Pots are very dirty. So what do? I don't know. Anyways, we actually got audio through the amplifier. So I'm going to make this one last clip. This is a Model 60 amplifier, not a 40B, and it's not a 60B. It's a Model 60 amplifier. I've verified that from downloading the Victor service manual for various models. So, and I'm also measuring the B plus on, I'm trying to find the other side of the choke. I'll bring this up a little bit and see what we get. You shouldn't go over 360. So I'm only at 105 volts. Okay, now let me shut it down. Let me shut it down and let me just change my lead to the other side just to see what side of the choke I'm on. I can't trace those wires through. Okay, let's try it again. And we're looking for 360 volts. Okay, that must be before the choke, because I'm only at about 95 volts in. So we'll turn it down. Isn't this fun? This is what ham radio operators generally do. Okay, we put this over on that side. That should be on the output side of the choke. And now one more time. And we'll stop it at 360. There we go. That's 100 volts. So this transformer is a little bit too strong. And of course I am using a solid state rectifier. I don't know what it would be if I had a 5U4 in there. I don't think this transformer is really going to work. I might hook up the 5 volts and put a 5U4 in there and see how it works. And I'm waiting for some of these other capacitors to start shorting on me. So that's about it. Progress. Okay, so this will be probably the last video I do on this. And I don't know if I'm going to go any further on this projector or not. But what I'm doing now is I have a 5U4 rectifier vacuum tube plugged in, and I've connected up to 5 volts. Now, hopefully I have everything connected right, so this could result in smoke. I don't know, but we'll see what we happen. I'm going to still bring up the B plus slowly and see. What I'm trying to do is see if I could at least get the transformer primary up to 120 volts and still be within the B plus tolerances. According to the schematic, the B plus should be no more than 360 volts, B plus. So let's see what I get. I'll start bringing it up now, and like I say, this could be risky. Okay, the 5U4 is okay, that's 120 volts in, 327 out of the rectifier tube. So actually that's pretty good. Let me see if I could get I'm at 120. Here's my speaker down here. My assistant. $327 volts. It's not 360, but this transformer would work. Okay, let's bring her down. I don't want it to run with those old capacitors too long, but what am I going to do with this thing? This isn't what I wanted to do. I really wanted to get this going the way it was built. So how do I make this projector work? Little hum there, but that's to be expected. So with the 5U4 vacuum tube rectifier in it, it brings the voltage down. So essentially this transformer would work, but I'd have to off-board it. I'd have to cable it. I'd also have to cable a 6 amp 5 volts up to the exciter lamp. This is not really what I wanted to do. I hadn't counted on the fried up transformer. It's just the way it is. But with a vacuum tube rectifier, the voltage comes down, and you don't want to use a solid state rectifier with vacuum tubes really on an old amp like this anyways. Maybe on newer ones it works. When the tubes are hit with the full B plus before the filaments are thoroughly warmed up, that sometimes that can shorten the life of the vacuum tube. But anyways, the thing is working. Let's bring her up one more time. Volts in. Let me, I think I had this on the right side, but let me see what it is on the other side of the filter choke. Well, that would work. So what do? I'll probably end up just throwing throwing the amplifier and the projector out. At least I got it to work. Not in the projector, but I got it to work. So that's something.